Hello, good morning everyone.
Good morning, ma'am.
Good morning. So, let's start today's session. First of all, let's recall back what we did in the last week. So, what we did, we have started discussing ER diagrams and we have gone through few important concepts and notations related to ER diagram. Even we have tried to draw simple ER diagrams based on some real world problems, right? I have found that I have posted one assignment also in the last week, right? And few of the students have not yet responded to the assignment. So out of I think 69, around 50 students have responded, but still around 20 students, 19 students have not responded. I do not know what is the reason. Because the assignment was not that difficult and we had a clear discussion regarding drawing the ER diagram in the last week. Also, we have conducted one laboratory session also, wherein we have discussed about how actually to draw the ER diagram by making use of one of the softwares, that is Jaya, right? So once again, I appeal all the students that whatever are the assignments those are provided, please work on those assignments prior to the deadline. Okay? And if you are having any doubts, feel free to ask the doubts. But it should not happen that you are not working on the assignments provided. Okay? Fine. So, also regarding the solution of this assignment, I am posting one video that discusses the solution, correct solution for the assignment, right? Because it is not possible actually to respond to every assignment with the problems, because many of the problems or many of the corrections in the design are common for many of the students, and that is why what I thought is, instead of giving the comments to every student individually, I have prepared one video demonstrating few of the representative solutions having some problems. I have discussed your problems in that video and also I have provided you with the correct solution for that problem statement. So I would suggest you to go through that video. I'm going to upload it on YouTube. So go through that video and assess yourself whether your design is correct or whether you are having any problems in your design. Right? So I hope I'm clear with this. Okay? Fine. Now, we have a discussion in the last week till the ternary relationship sets, and also we have discussed that how to convert a non-binary relationship set into a binary relationship set. And we also mentioned that there are the advantages of having the binary relationship sets instead of having the NRE relationship sets. Okay. Now, in today's session, we are going to focus upon few design issues. Those we may have while designing the ER diagrams. So many times it happens that we are having some dilemma while drawing the ER diagrams, whether it should be the NTT set or whether it should be better represented as the relationship set, whether we should go for a binary relationship or whether it is better to go for NRE relationship, right? What would be the attribute for the relationship set, something like that. So we are having certain issues those we may face while actually drawing the ER diagrams. So we are going to first discuss upon these issues, and then we are going to focus upon one of the advanced concepts, you may say, and that is the weak entity sets. Okay, so this is the agenda for today. So let's begin with the design issues. So the very first design issue that we have listed here is use of entity set versus attributes. So many times we may have a confusion whether a particular thing that is being mentioned in the problem statement, whether that can be suitable as the attribute for the entity set, or that particular thing can be modeled as separate entity set. So usually the choice depends on the structure of the enterprise being modeled, and also it depends on the semantics that is associated with the attribute in the problem statement. So I'm going to give you one example to clarify this particular design issue, whether something needs to be represented as a separate entity set or the attribute of the entity set. So let's see one example. Once again, the example of our instructor entity set. Right? Now, what are the attributes those we have identified for instructor entity set? We are having ID, we are having name of the instructor, and we are having salary of the instructor. Okay? Now, let us assume that we need to store phone number also of the instructor. Phone number also of the instructor. Now, obviously, what we may think of is it can definitely be added as one of the attributes for instructor entity set. Do you agree with me? If I want to store phone number of the instructor, obviously what I may think? I may think of adding one more attribute phone number for the instructor entity set. Am I correct? Yes?
Yes.
Right? So this is a common thinking, and that is not wrong, right? We may add phone number as the attribute, right? Further, we may think of making this phone number attribute multi-value if we would like to store more than one phone numbers for that particular instructor. Am I correct? Yes?
Yes, ma'am.
So this is also possible that I may think of making this phone number as multi-valued attribute if I want to store more than one phone numbers, right? But now just think on, if it is mentioned in the problem statement that along with the phone number I need to mention few details also. Say for example, location. So whether this phone number is residence number, whether this is the office number, whether this is the mobile number or something like that. So in addition with phone number, according to my problem statement and the semantics that has been provided, I want to store certain additional information also related to the phone number, right? So if this is the case, then I may need to think of whether phone number can be added as the attribute for my entity set instructor, or shall I have a separate entity set as phone number? So if I need to store some more information about that particular phone number, then definitely I may think of creating a separate entity set, that is phone. Okay, and I may have the relationship set between instructor and phone, so that I can associate a particular instructor with a particular phone number, right? And attributes for this phone number might be the phone number along with the location. So this additional information can be stored now. Okay, and let's delete now the earlier attribute, that is phone number, from the instructor. So this can be my design. So instead of adding attribute phone number to the instructor set, what I have done? I have added other entity set, that is phone. Right? And why this has been done? Because it was the requirement to store some additional information about the phone number, like location. Right? So in that scenario, based on the semantics that we would like to depict, this kind of design might be suitable. So this is the very first issue, that sometimes we need to make a decision whether a particular attribute or a particular information can be better depicted or better modeled as the attribute of the entity set, or it can be better modeled as separate entity set. Right? Are you getting me? If you have any doubts, please speak up. Are you getting me?
Yes, ma'am.
May I proceed?
Yes,
May
ma'am.
I proceed? Okay. Fine. So this was the first design issue that we need to consider sometimes while designing the ER diagram. The next issue is use of entity set versus relationship set. Now, once again, we might have the dilemma that whether it would be better to depict something as the entity set or the relationship set between two entity sets. The possible guideline that already we have discussed is to designate a relationship set to describe an action that occurs between entities. So if after reading the problem statement, if we find that these two entity sets are being associated, there is some action between these entities, then definitely we may designate that kind of action as the relationship set. Okay, but sometimes we need to think of to come up with a good design. Okay, this is the general guideline. Now, let me give you one example here. Suppose I am having some items. I am having some shop, let us assume. Okay, and I am having some items to sell. Right? And I am having few customers who are buying those items. So I am having customer who are buying those items. So I am selling those items and customers are buying those items. Right? So I am having these two entity sets with me. I am not depicting here the attributes right now. Okay? Now, if I want to depict this kind of action, sale of items to the customers, what I can think of how to depict this sale of the items? Yes? Have you understood my problem? What we want to do? We want to show that there are certain items and we are selling those items to the customers. Right? And the related information we are supposed to store. Are you getting me? Roll number 304, Rahul.
Yes, ma'am. Yes, ma'am.
Are you able to understand?
Yes, ma'am.
So what we are trying to do?
There are
Rahul?
several.
Yes.
There are several items and customers. We want to buy them item.
Correct. So we want to come up with some ER diagram that will store the item data, that will store customer data, and also the data related to sales. Which item is being purchased by which customer, that also we would like to store. Is that correct? So,
Yes, ma'am.
what would be the possible solution? How I can depict it using ER diagram? See, I am having item ID. I may have the price of the item. I may have name of the item. These are the attributes along with this item entity set. For customer also, I'll be having customer ID. I'll be having customer name. I may have the contact details of the customer. So those are the attributes of the customer. And what I want is, I want to store now the data of related to sale. So which item is purchased by which customer? So how I can depict that? May I use a relationship set between them like this? And may I give them this relationship name as sell? Yes? I'm selling some items to the customers. So by default, I'll be having the attributes like item ID and customer ID. So I'll be able to find out which item is sold to which customer. If I also want to store the quantity sold, I may have a descriptive attribute here. If I want to store date, I may have attribute over here, date. Correct, na? So shall I proceed with such kind of the design? Any thoughts? Roll number 306. Are you there?
Yes, ma'am.
So shall we go with this design? Do you find this design efficient? Shall we go with this?
No, ma'am. The relationship set cell I didn't understood properly.
So what we are supposed to store?
Supposed to.
May I ask? Roll number 315. Niharika, are you there?
Yes, ma'am.
So whether we can go with this design?
No, ma'am.
Why?
Because it is not efficient.
Why? What is the problem? What we want to store? We want to store the information like which item is being sold to which customer. So I am having the relationship. Even descriptive attributes are there. Those are storing, say, quantity sold, date might be. So what is harm in this design? May I proceed with this design? If not, why?
There is no clear mentioning of the details that need to be mentioned.
So what kind of solution you will propose? Yes?
New entity set.
New entity set. So what would be the attributes for that new entity set? See here.
Purchase
Yes.
data.
So I will be having new entity set. Okay. New entity set. So I may give name to this entity set. Say something like invoice. Right? What I can do is, for this invoice entity set, I'll be having the attribute like invoice number. I'll be having the attribute like invoice date. Then instead of having this relationship, what I can do is I can have a relationship between item and invoice. I can have a relationship between customer and invoice. Right? So every invoice must have a customer associated. So I may put here total participation. Every invoice is associated with exactly one customer. So many to one relationship. Right? Invoice is participating totally in this relationship. I may have such kind of a design. Right? Now in this relationship, what I'm going to store? I'm going to store which invoice is having which items. So, and if I want to store quantity of that item, I may have the attribute here, that is quantity sold for that item under that invoice. Correct? So I may store the information about the item sold under a particular invoice, and in this relationship I'll be depicting which invoice is meant for which customer. Right? And if I go with such kind of a design, instead of the earlier one having the relationship as sale between the item and customer, I think this would be more clear. Right? There is little duplication also of storing the information. See, if I'm having sale as the relationship in between, and if I'm storing date also, then for every item, if the customer is purchasing say 50 items on a particular date, then 50 times that date needs to be repeated. But if I go with this design, I'm having one invoice on that date with some invoice number. Right? So date is being stored only once here with invoice, and whatever may be the number of items under that invoice, I'm going to store all those items in this relationship set. So no duplication of date along with every item that is sold. Are you getting me? Yes? Are you getting me, or may I repeat once again?
Repeat it, ma'am.
Okay. So have you understood the problem first? Aishwarya, have you understood the problem first?
Yes.
So what we want to store? We want to store items, we want to store customer, and we are supposed to store the sales data. Is that correct? So two designs, those we may come up with. One design is like item, customer, two entity sets, and in between these two entity sets we are having sale as the relationship set. Right? If I go with this kind of a design, what I need to do is I need to add few descriptive attributes here like quantity sold, and also I may require to store the date when I have sold that particular item. Is that correct? Aishwarya, are you getting me?
Yes, ma'am. Yes, ma'am.
Okay, so this is the design that we may come come up with. But if I'm having that kind of a design, I'll be storing some descriptive attributes, no doubt, but whichever, if a customer buys say 50 items on a particular date, then associated with that item, I need to store the same date 50 times because he has purchased 50 items. Am I correct?
Yes, ma'am.
No doubt I'm able to store the information, right? But I'm saying that this kind of a design may not be efficient because, say for example, quantity for different items is different. So no doubt I need to store it at any cost. But date would be replicated, date would be duplicated if the person buys 50 items on the same date. Is that correct? Also, what needs to be done by default for this sales relationship, I am having item ID and customer ID. So for every entry, also I am storing the customer ID along with the item ID. So item ID, customer ID, quantity and date. 4 attributes actually I am storing in this relationship. These 2 are the descriptive ones and 2 are by default primary keys of the participating entities. Right? So some of the information gets unnecessarily duplicated. So instead of this, if I think of some other design, like I can have invoice as the separate entity set, I'll give that invoice some number, invoice number, which will act as a primary key for invoice. And if I store date of that invoice only once in this entity set, and if I create a relationship between invoice and item and invoice and customer. So under that invoice, whichever are the items purchased, those can be stored in this relationship. So I'll be having item ID, invoice number along with this quantity. Okay, date is being stored here with invoice only once for that invoice number, right? And I'm having relationship between customer and invoice. So whoever is the customer associated, that customer I'm going to store by making use of this relationship. So I know which invoice belongs to which customer. I also know which items are included in which invoice. So the same thing I can depict in this way also. But if I look at both these designs, this design is more clear, more clean and more efficient than this particular design. And that is why in such kinds of situations, we need to think of whether a particular action can be depicted as the relationship, or is it better to go with the entity set, right? Having few more relationships added so that we can have more clearer design, right? So I think you must have understood the concept now, and among these 2 designs we may pick this design because it is giving me more clarity of whatever I am doing. It is providing me more efficient way of storing the data than this. Is that correct?
Yes, ma'am.
So I hope now you must have understood the concept. So this is the second
Yes,
issue,
ma'am.
right? So whether we should go with entity set or whether we should go with a relationship set to model some information that is provided in my problem statement. Okay, so let's proceed further with the next issue. So let's clear the screen now. So the third issue that we are going to discuss is whether to go with binary relationship or whether to go with the n-ary relationship. So in fact, we had a detailed discussion related to this concept in the last session. So I'm not going to discuss once again these concepts, but we have gone through this simple example wherein we had a ternary relationship parents, right, among three entity sets, child, father and mother, and we also had a design, other design, child with father, one relationship, child with mother, another relationship, right? So this is making use of binary relationships and this is making use of ternary relationships. So depending on the problem statement and depending on whatever is the model that clearly depicts the semantics, right, we should prefer to use that kind of a relationship set. So if it is possible that we are having all the information available at a time, then we may think of going with this ternary relationship. But if there is a situation that not all information is available at a time or some information is missing, right, then in that kind of a situation we may prefer to go with such kind of a design, right? We had a discussion earlier in the last session regarding this. Okay, so please consider that this is a third design issue that we may think of. The final design issue that we are going to discuss is the placement of relationship attributes. Placement of relationship attributes. So please note that the cardinality ratio or the mapping cardinality of a relationship can affect the placement of the relationship attributes. I'll repeat. The mapping cardinality of a relationship can affect the placement of relationship attributes. So what I mean by that, let us see with examples. We know that we are having four mapping cardinalities: one to one, one to many, many to one, and many to many. Right? Now, the attributes of one to one or one to many relationship sets can be associated with one of the participating entity sets rather than with the relationship set. So what we mean by that? For one-to-one relationship set, the relationship attribute can be associated with either one of the participating entities. Whereas, if my cardinality ratio is one to many, then the descriptive attributes of one to many relationship set can be repositioned to only the entity set on many sides of the relationship. So what I mean by that? Let me give you one example. So let us assume that we are having advisor as the relationship. And let us assume that this is one-to-one relationship set. And we have seen earlier that date is the attribute, descriptive attribute for the advisor relationship set. Okay, so here is the situation. We are having instructor entity set, we are having student entity set, and between these two we are having advisor as the relationship set. And for this relationship set advisor, we are having this descriptive attribute, that is date. Okay, and this date is for storing the association, date of association between instructor and student. Okay. Now, if relationship that is one-to-one, if this relationship is one-to-one, what we mean by one-to-one relationship? This means that one instructor is associated with at most one student and one student is associated with at most one instructor. So that is one-to-one mapping cardinality. Okay. Now, if I am having this relationship set as one-to-one, then this descriptive attribute date can be placed with any of these entity sets rather than this relationship set. I'll repeat. The attribute date can be associated with any of the entity sets rather than associating it with the relationship set, because it is one-to-one relationship. So one student, one instructor, one student. So instead of having this attribute at this place, what I can do is I can add date attribute here. So date when the association of that student started with the instructor, or I may associate date attribute here when the student gets associated with the instructor, because every instructor is having one student, so only one date is available. So I may store date here or I may store date here if it is one-to-one relationship set. But if it is one-to-many relationship set, if it is one-to-many relationship set, what needs to be done? If it is one-to-many relationship set, what we mean by that? One-to-many, one instructor may have more than one students, right? One instructor may have more than one students, but one student is associated with at most one instructor. So this is one-to-many, one towards this side and many towards this side. And how we are interpreting this? One instructor may be associated with more than one students and one student is associated with at most one instructor. That is how we interpret one-to-many relationship. Now, we are having this date attribute with this advisor. But if my mapping cardinality is 1 to n, then what we can do is we can place this date attribute towards many side of the entity set. So this date can be placed here along with student. So every student is having at most one instructor. So along with every student, I may store the date. So I may remove this attribute from here and I may place this attribute towards this side, student. Right? But I can't place this date with instructor. And the reason is one instructor is associated with more than one students. So more than one dates need to be stored. And there should be a correlation with student, which date. So it is not advisable to use this date attribute as an attribute of instructor one side, but it should be the attribute towards many side. So if I am having the cardinality as 1 to n, 1 to many, then the descriptive attribute of the relationship can be placed towards the many side of the relationship set. So this date can be placed as the attribute of the student. Are you getting me? If you have any doubts, please let me know. May I proceed? May I proceed?
Yes, ma'am.
Yes, ma'am. Yes,
Okay.
ma'am.
So 2 more cardinalities now are remained. Right? So what are those? Many to one. Once again, in many to one, the same logic we may apply. So if it is many to one, so if I am having this relationship advisor that is many to one, then obviously what my rule says, instead of having this descriptive attribute to the relationship, what I can do? I can place this towards instructor side. So here I can place that date. Okay, towards many side. Okay, but now if this advisor relationship is many to many, if this advisor relationship is many to many, then this date must be the attribute of this advisor relationship set. This date must be the attribute for the advisor relationship set. We cannot place this attribute to either of these sides because both are many. Okay? So in this case, this descriptive attribute must be placed at the relationship set only. Okay? So I am summarizing once again. If my relationship set is 1 to 1, then what I can do? I can place the descriptive attribute of the relationship set at any of the sides because both are 1. If it is 1 to many or many to 1, what I can do? I can place the descriptive attribute towards many side. Okay? And if it is many to many, then I must have the descriptive attribute placed at the relationship set only. Okay? So these are certain considerations while designing the ER diagram. So I hope you must have understood all those 4 design issues. If you have any doubts, please let me know. Any doubts? Yes. What are the 4 design issues those we have considered? The first one is use of entity sets versus attributes, use of entity set versus relationship sets, use of binary versus n-ary relationships, and finally the placement of relationship attributes. So these are 4 important design issues those we should consider while designing the ER diagram. If you have any doubts, please let me know. Got the concepts? Yes? May I ask roll number 320, Neil?
Yes, ma'am.
Have you understood the concepts?
Yes, ma'am.
So while designing ER diagram, are you confident that you can think of these things?
Yes, ma'am.
Fine. So let's proceed now. I'm going to introduce one more advanced concept, that is weak entity sets. Right? I'll introduce today, and in the next session we'll have a detailed discussion. So what is weak entity set? So far, whatever are the entity sets, those we have discussed. Those entity sets were the strong entity sets. Strong. So what I mean by strong entity set? Strong entity sets are the entity sets. Those are having their own primary keys, and these entity sets are independent. So if I consider any strong entity set, it is having its own primary key, right? And this entity set is not dependent actually on any of the other entity sets, right? But in case of weak entity sets, the weak entity sets, as the name suggests, for their existence, they need to depend upon some strong entity sets. I'll repeat. Weak entity sets are the entity sets those depend upon some other strong entity sets, and the weak entity set is not having its own primary key. The primary key of the weak entity set is formed by making use of the contribution of the strong entity set associated. So I'll be giving you one example, right? We are talking about the university database, right? And we are having the problem statement like this. The university has various courses and the university maintains a list of all classes or sections those are taught under those various courses. Each section is identified by a course ID, section ID, year and semester. Right? So these four attributes are actually identifying individual sections. But if we look at this section is identified by these four attributes. It has been mentioned, course ID, section ID, year and semester. But in fact, this course ID is the primary key for other entity set, that is course. Right? So, to have its own existence for the section, this section needs to take help from other entity set, that is course. Right? And that is why we may depict in ER modeling this section entity set as the weak entity set that depends upon the strong entity set, that is course, and how it can be depicted in ER diagram. Just look at it. Course is the entity set with three attributes: course ID, title and credits. Okay, so course ID being the primary key for the course. Whereas, as I mentioned, section depends upon the course. Section of the course depends upon the course. Right? So, we are depicting this section as the weak entity set. So, weak entity set is depicted with this symbol, with this notation, double rectangle. So, this double rectangle is depicting that this section is the weak entity set. Also, please note that this section, which is a weak entity set, is not having the primary key of its own. But whatever we have mentioned, the underline, dashed underline attributes, right? These are the discriminator keys. Okay? And in between the strong entity set and the weak entity set, in between the strong entity set and weak entity set, we are having this relationship depicted as double diamond. And this is known as the identifying relationship set. Right? So the relationship set between weak entity set and strong entity set is depicted as double diamond instead of a single diamond. This is the notation, and this is known as the identifying relationship set. Okay, so why are this relationship set? This weak entity set depends upon this strong entity set. Okay, so with this introduction, we are going to conclude our session today, and in the next session, we'll be focusing more upon this concept of weak entity set with few more examples also. Okay, so I hope you might have gained a little insight what we mean by a weak entity set. Weak entity set always depends upon the strong entity set. Strong entity set is having its own primary key. To form the primary key of the weak entity set, we need to take help from the associated strong entity set. In between weak entity set and strong entity set, we are having the identifying relationship set that is denoted as double diamond. Okay, and always this relationship is one to many relationship. So towards the weak entity set, we are having many, and this weak entity set participates totally in this relationship set, identifying relationship set. Okay, so with this, let's conclude today's session, and we are going to continue the discussion related to weak entity set in the next session. Okay, once again, I'll appeal all of you to go through the video for the solution for assignment number 2. Okay, and if you have any kinds of doubts, please report the doubts in the comment section. Okay, fine. So let's conclude. Thank you.